Newton's first law describes how an object moves when no force is acting on it. A stationary object remains at rest until you apply a force to it. Once you set it in motion, the object continues to move at a constant speed until it strikes another object.
Just like we can see here in this image, the Newton's first law is implied on the kite with a vertical velocity and the lift that's balancing both the weight and the vertical pull. The second Newton's law is related to the Bernoulli's theorem. This is because when flying a kite, above the kite the air is not slowed down, and sometimes it's actually sped up so that pressure either stays the same or decreases. The pressure difference between the kite's bottom and top surfaces, which eventually causes the lift force. In this image, we can see how the horizontal tension force acts as the aerodynamic lift and drag and the tensional control line. Then there's the lift, there's the drag, and there's the force of gravity.
Newton's second law describes how force and acceleration are related. A kite flying through the air is a good example of this principle. The force acting on the kite in flight include the weight, the aerodynamic lift and drag, and the tension in the control line.
Newton's third law states that every action has an equal and opposite reaction. The kite is kept in the air by the tension in the string and the force of gravity. The kite is kept in the air by lift. To rise and lower the kite in the air, we can use lift by increasing and reducing the tension in the string.
This relates to Bernoulli's theorem. Bernoulli's theorem explains why the kite has lift. The kite creates an obstacle to the normal airflow that causes the air to change direction and speed. If you hold the kite out flight to the wind like a wing, beneath the kite the wind is slowed down and therefore the pressure of the wind increases to compensate.